So on example 5 here, we're going to find a particular solution to the inhomogeneous system. And remember, there was a little typo in there. That should have been a plus. So we're going to go ahead and solve it with a plus there. It's really messy if you work it out with a minus sign. So we're going to solve it with a plus. And the way we're going to attack this is we're going to use the information that we had from the previous example. So a lot of the work has already been done in example 3 and example 4. So let me just remind you of what we figured out in example 3 and example 4. We already figured out the fundamental matrix, and we found its inverse, and we're ready to go to find the solution to the inhomogeneous system. So what we learned at the beginning of this lecture is that you can find your derivatives of the u's by doing the inverse of the fundamental matrix times g, where g is the g is the stuff right here. That's our g of t. It's the inhomogeneous terms of the differential equation. So I'm going to go ahead and write those out. My u prime is my psi inverse times g. Now, psi inverse, we figured this out in example 4, so I'm not going to work it out from scratch again. Example 4, that's what I'm using right here to get my psi inverse, and I'm just going to copy that down from what we had as the answer to example 4. So negative sine t, cosine t, and then cosine t plus 2 sine t, plus 2 sine t, and sine t minus 2 cosine t. That was the inverse of psi. Now I'm going to copy my g of t. That's coming straight from the differential equation here. So this is cosine t and sine t. And I need to multiply those through. So I see on the first row, I've got minus sine t times cosine t. And then I've got a cosine t times sine t, so those will cancel. And I'll just get 2 sine squared t. So the way I got that was I multiplied this row by this column, and I saw that I had two terms canceling, a term of cosine t, sine t, as occurring with a negative and with a positive. So that's why I canceled those out right away. Now I'm going to multiply this second row by that same column. So I see I've got cosine squared plus sine squared. So that's a 1. Minus 2 sine t cosine t. 2 sine t cosine t. And I think that, remember, that's u prime. So that's u1 and u2 prime. What I'm going to do is I'm going to use some trigonometric identities here. The trigonometric identity I'm going to use to make it easier to integrate is that sine squared of t is equal to 1/2 times 1 minus cosine 2t. That's an old trigonometric identity. If you don't remember that, we've got some lectures on trigonometry here on Educator, and we also use that pretty heavily in the Calculus 2 lectures here on Educator. In Calculus 2, we learned how to integrate trigonometric functions, and one of the tricks there was when you have a sine squared or cosine squared, you want to use this double angle identity. So that's what I'm kind of recalling that from Calc 2. And so if I write this out, I'm going to get, well, 2 sine squared of t would just be 1 minus cosine of 2t. And then on the bottom, I have 1 minus 2 sine t cosine t. So I really want to think of those as, remember, that's u prime. So that's u1 and u2 prime. So u1 is the integral of that first row, 1 minus cosine 2t dt. And so if I integrate that, I just get t. Now, the integral of cosine is sine, but since it's cosine of 2t, it's 1/2 sine of 2t. You don't have to include the constant when you're finding this u1 and u2. If you did include the constant, it would just give you more multiples of the homogeneous solution. So you don't have to worry about the constant here. The u2, Actually, I think I'm going to work a little more with u1. I'm going to use another trig identity there, which is that the sine of 2t is equal to 2 sine t times cosine t. And so t minus 1/2 sine 2t is just t minus 1/2 of what I just wrote. So t minus sine t cosine t. I think that'll be a little easier to work with later on. Now I'm going to go ahead and find u2. That's the integral. This was u2 prime. That top row was u1 prime. So I'm going to integrate u2 prime to get u2. So 1 minus 2 sine t cosine t. Now there's a lot of ways you could integrate this, but I think the one that's going to work the best is to do a little substitution here for cosine t. And I'd like to use a u substitution, but since I'm already using the variable u for something else, I'm going to use a different variable. I think I'm going to use w. W equals cosine t. And so dw is equal to negative sine t dt. And so that'll give me, if I plug those in, that'll give me the integral of minus 2w, plus 2w, because the minus is included in the dw, plus 2w dw. And so the integral of 2w is just w squared, so that'll be very easy. So when I integrate this, the 1 just integrates to t, the 2 sine t cosine t integrates to w squared, so that's plus cosine squared t. And so I've got my u2. We're going to figure out how to use that on the next slide, but let me just quickly recap what we did here. We already found psi inverse back in example 4. So our psi inverse, that comes from example 4. If you don't remember how we got that, just go back and read over example 4. You'll see where it came from. And our g is coming right here from the inhomogeneous terms in the differential equation. So I plugged those in right there. I multiplied the 2 rows there, and there was some cancellation going on, and it simplified a bit into 2 sine squared and 1 minus 2 sine t cosine t. Now, my sine squared t, I used this old trigonometric identity. We used it a lot in calculus 2 to convert that into 1 minus cosine of 2t. And so then what I have here is u1 prime and u2 prime, and I integrated each one of those. A little substitution here, turned it into 1/2 sine of 2t, and then I used this old trigonometric identity to simplify that into sine t times cosine of t. And then the second one, I used a little, I wanted to call it a u substitution, but since I'm already using u for something else, had to call it a w. So w equals cosine t, and then dw equals negative sine t. So I just have 2w, and that integrates to w squared, so we get t plus cosine squared t. That t came from that 1 right there, and then the rest of it gave me the cosine squared t. So that's my u1 and u2. I'm going to keep going with that on the next slide. So in our next slide, we have our u1 here. That's actually not quite what we had for u, so I'm gonna, there's a couple extra terms here, a little typo here, so let me fix that quickly. The u that we had was t minus sine t cosine t, and in the bottom part, let me erase that and fix that quickly. In the bottom we had t plus cosine squared t. So that's the answers that we got from the previous slide. Just go back and watch that previous slide if you don't remember where they came from. And so now let me show you how you use these to write down the complete solution to the problem. So our particular solution is, let's see, it's u1 times our x1 plus u2 times our x2. And so that's going to be a little elaborate and complicated. Let me write that out. Our u1 is t minus sine t cosine t. And our x1 we get from this first column of the matrix. So that's 2 cosine t minus sine t, and cosine t in the bottom. Now, plus u2, so that's t plus cosine squared t, t plus cosine squared t. And our x2, get that from the second column of the fundamental matrix. So cosine t plus 2 sine t, and sine t on the bottom. Now, this gets to be a little ugly and complicated, but it's going to simplify nicely after we plow through all the mess. So let me work through that first row here. I see I've got 2t cosine t minus t sine t minus 2 sine t cosine squared t plus sine squared t cosine t. And I'm going to go ahead and add on the first row of the second term there. So plus t cosine t plus 2t sine t plus a cosine cubed t plus 2 cosine squared t sine t. So very long and messy, but I'm hoping there's going to be some good cancellation coming in there. In the bottom, we get t cosine t minus sine t cosine squared t plus t sine t plus cosine squared t sine t. So I'm really hoping some of this will simplify, and it is customary when you do variation of parameters to get very long, complicated solutions, and then they do somewhat simplify. So if I look at this top term here, I see I've got a 2t cosine t, and I've got another t cosine t. So I'm going to put those together and get 3t cosine t. Now, minus t sine t plus 2t sine t, so plus 2t sine t. Minus t plus 2t, so just plus 1 after all that simplifies. Now, minus 2 sine t cosine squared t, and plus 2 cosine squared t sine t. So those two terms just cancel each other out. That's really nice. And then I see I've got two other terms here, plus a sine squared t cosine t. Oops, forgot my t there. Cosine t plus cosine cubed t. Now in the bottom, I see I've got t cosine t plus t sine t. And then I've got a minus sine t cosine squared t plus cosine squared t sine t. Those two cancel. So it really did cancel quite nicely. And it actually is going to work out even better because if you look at these two terms, I could factor out a cosine t times sine squared t plus cosine squared t. And of course, cosine squared plus sine squared is just 1. So those two terms are going to combine and just give me a cosine t. And so I think what I'm going to do is factor out a t from whatever terms I can. I've got t times 3 cosine t plus sine t. And then in the bottom, I've got cosine t plus sine t. And I still have this cosine t. So let me not forget that. It's just in the top. So I'm going to factor that out on the right, get a cosine t. And I'll just say I have 1, 0, because that term only appears on the top, and everything else canceled out of the bottom. Now I think on this one, we were just asked to find a particular solution. So that is my particular solution. So let me recap and show you all the steps that went into that. This psi, first of all, came from solving the homogeneous system. We did that back in example 4. So that's where we found that psi. So that's example 4 coming in and being useful here. If you haven't watched example 4 recently, just go back and check example 4. You'll see exactly where that psi came from. And these two entries for u, that was u1, that was the u2 that we found on the previous page. I originally wrote it wrong in my slides, so I just corrected it right there. That's the t plus cosine squared t, which we found on the previous page. And then our general form for the particular solution is u1 times x1 plus u2 times x2. So I copied my u1 down there, copied my x1, that was the first column of psi. There's my u2, and then I copied my x2, that's the second column of psi, x2. So we always have this form, u1 x1 plus u2 x2. Every time you do variation parameters, you got that form. And then multiplying this through the first row, that gave me these first 4 terms there. Multiplying this through the first row gave me the next 4 terms. So very ugly expression there. And then multiplying this through the second row gave me those 2 terms. And then multiplying this through the second row gave me those 2 terms. So we get this really horrible expression, but it's nice. A lot of things cancel. These 2 terms cancel. This one cancels with this one. This term combines with this term. The t sine t combines with the 2t sine t. So we end up with 3t cosine t, t sine t, and then these other 2 terms, sine squared t, cosine t plus cosine cubed t, and those 2, we can factor out and simplify that one just down into cosine t. So this whole thing just turns into cosine t. In the bottom, we get terms canceling. Those big terms cancel. We just get t cosine t plus t sine t. And then what I see now, basically I'm done. I just wanted to factor the t out and make it look a little nicer. So I factored out that t from the first 4 terms, factored that out here. And that left me with a 3 cosine t plus sine t and a cosine t plus sine t. And I still had that 1 term of cosine t. Can't factor a t out of that, so I had to write it separately. So there it is, 1, 0 times cosine t. So that's the particular solution to that inhomogeneous system that we started with way back in example 4, and then we had it again in example 5. If you wanted to find the general solution, it would really be no more work, because what you would do is you would just take the homogeneous solution and then add on the particular solution. And we've already found both of those. I'm not going to copy them again because they're kind of long and there's really nothing to be gained here. But we found the homogeneous solution in example 4. And then this particular solution is what we just found right here. So if you wanted to, you could just put those together and get the general solution to that inhomogeneous system of differential equations. So that's the end of our lecture on solving inhomogeneous systems of differential equations. Remember, we actually had 2 methods. There was undetermined coefficients, that was the previous lecture, and then variation of parameters, that was this lecture. So 2 completely different ways of finding this particular solution, but they both work, and they both end up giving you solutions to inhomogeneous systems of differential equations. And that actually wraps up this chapter on systems of differential equations. Our next chapter is going to be on numerical methods, so totally different stuff. I hope you'll stick around and watch that chapter as well. In the meantime, you are watching the Differential Equations series here on Educator.com. My name is Will Murray, and thank you very much.